Okay, here we are talking about piecewise defined functions. Let's say we wanted to graph f of x is x squared plus 1, but we only want to use x is greater than or equal to 3. We don't want the whole graph, we just want 1/2 of it. We call that a restricted domain. Well, here's the graph of y equals x squared plus 1. Just regular x squared shifted up 1. We don't want this whole graph. We want to start here at x equals 3. That would be the point right there, 310. Just plug in x equals 3. 9 plus 1 would be 10. And we want to start here and keep everything to the right of that point. Don't think up and down, think left and right. We want x is greater than 3. All these x's, 3 and greater. So I've highlighted it here. That's this blue section of the graph, starting here at the point 310 and going to the right. And then, of course, we would erase the rest of the graph. Here's our graph for f of x is x squared plus 1, using only x is greater than or equal to 3. This, of course, should have an arrow on the end. This goes on forever. It just cuts off because I'm at the edge of the picture here. And I really should have a solid dot here at that point, 310. Okay, more complicated example. We've got f of x is this line, 2x minus 1. On this region, x is less than 0. And y equals x cubed for x is greater than or equal to 0. Okay, so I've graphed both. Here's the line in black here, y equals 2x minus 1. And the blue, y equals x cubed. This is clearly not the final answer. This is not a function. This horribly fails the vertical line test. But I don't want all this stuff. I want half of the line and half of this blue cubic. So for the line, I'm starting at x equals 0, right here at that point, 0, negative 1. And I want to keep the half of the line where x's are less than 0, this left half of the line from here over. And then similarly for the cubic, I keep the right half of the cubic, starting here at 0, 0, the right half of the cubic, x is greater than 0. So I've highlighted it here. In red is the chunk of the line we're going to keep from x equals 0 left, and in green is the chunk of the cubic, x cubed, from 0 to the right. And then we erase the parts we don't want. Here's our final answer. Notice this is a function. It passes the vertical line test. We've got a solid dot here on the cubic because we're using that for x greater than or equal to 0. When we have the equal, we get a solid dot at that endpoint. For the line, we don't have an equal, so we get an open circle at x equals 0. Okay, and one more example. We want to consider this piecewise defined function. We've got this line 3x plus 2 for x is less than negative 2. This absolute value shifted to the right 1 and up 4 between negative 2 and 1. And this square root function, that's shifted left 2 and down 1. And we're using that formula when x is greater than or equal to 1. So if we wanted to do some evaluating, if I wanted to say plug in x equals negative 3, first I have to figure out which formula to use. So when x is negative 3, I have to look at my categories over here and see which one negative 3 fits into. Okay, so is negative 3 greater than 1? No, it's not. We would not use this third formula. Now, negative 3 is less than negative 2, so I would use this top formula, 3x plus 2, to evaluate f of negative 3. Remember, inside here is an x. F of x, the output, this negative 7, is the y that goes with that. If I wanted f of 0, I look over here and see which category 0 falls into. 0 is between -2 and 1, so I would use this middle formula to find f of 0. You can see we would get 5. If I wanted f of 2, 2 is bigger than 1, so I would use this third formula for 2. And you can see we would get 1. Okay, now if we wanted to graph this, here's what all three of the graphs would look like if they were all together in one picture. It's clearly not the final answer. This is not a function. I don't want all of this. I want the line only on the section when x is less than -2. So here's my line. Y equals 3x plus 2. I want to start here at -2 and only keep the right half of that. That will be this section down here. For this absolute value graph, I only go from -2 to 1, so I'm going to keep from -2 up to 1. And then for this square root, I only want when x is greater than or equal to 1. So here on the square root graph, I go to where x equals 1, right about in here, and I'll keep this chunk of the square root graph. Okay, so I've highlighted those. Here on the line, y equals 3x plus 2. When x equals -2 on the line, we would have this point, -2, -4. I only want x less than -2. Don't think up and down, think left and right. So I'm going to keep the left chunk of that line below x is -2, back here. For this absolute value graph, I want to go from -2 up to 1. X equals -2 to x equals 1. Keep this blue section of that absolute value graph. Happens to end there at that little corner, but that's just a coincidence. And then for the square root here, I'm starting at 1 and keeping everything above 1. So all of these x's for that graph. And then we erase all the parts we don't want. This is what our final graph will look like. Notice I've got the solid dots and the open circles. The piece of the formula that has an equal to gets a solid dot at that particular x value. If we don't have an equal to, we get an open circle. So the line has no equal. There's no equal right here at -2, so we have an open circle. The absolute value does have an equal at -2, so he gets the solid dot, but there's no equal to at 1, so an open circle at 1. And the square root here does have an equal at 1, so it gets a solid dot. And you can see here what's left over. This final graph does pass the vertical line test. This is, in fact, a function. Okay, that's piecewise defined functions. You're going to want to practice that on your own. Click on some of these other videos that are popping up now to watch similar videos for graphing functions.